Hey there, I'm Alejandro. Welcome back for day 303 of me doing Daily LeetCode Challenge with 31 years worth of green contributions here on GitHub. So today's one is from May 15th, 2025, and without further ado, let's get straight into it. Okay, today we get LeetCode Easy. Problem 2900, longest unequal adjacent groups, subsequence 1. Okay, this is going to look like a beefy problem for an easy. But let's see what this is about. You're going to string array words in a binary array groups, both of length n, where words of I is associated with groups of I. Your task is to select the longest alternating subsequence from words. Sounds like a DP problem already. Yeah, longest too, so it's a maximization problem. So probably going to be either DP, greedy, or divine conquer. But it isn't easy, so let's see what this is about. From words, a subsequence of words is alternating if for any two consecutive strings in the sequence, and the binary array groups differ. Essentially, you're to choose strings such that adjacent elements have non-matching corresponding bits in the group's array. Oh, I see. Is groups just zeros and ones? Let me look at the constraints. I see. Okay. Essentially, you're to choose strings. Okay. Formally, you need to, yeah, we can do DP with like essentially the current digit, right? And there's only two current digits, so it's like 2 times n is still O of n, kind of a thing. Essentially, you're to choose strings. This is, longest common subsequence, but harder. Longest increasing subsequence, but harder, which is a medium. Okay. Formally, you need to find the longest subsequence of an array of indices. Find the words corresponding to those indices. Oh, I see. So it's just like get the list of indices. Okay, so is this backtracking then? Because I need the actual thing? That's annoying. I can't just return the digit. Yeah, so this is 100, which means we can go all the way up to n cubed. Okay. Okay. I mean, we can just do like prevs, right? Right, so what I'm thinking is something like def dp self takes in an index I per bit, right? Is set bit bool. This will be an int, right? Right. Right. So this will be if I comma set bit and self.memo bit assert bit and 0, 1 comma bit it's a group, but I don't have return self.memo of comma bit as return res if words self dot groups words comma groups assert length of words equals length of groups. Is that given to us? Yeah. Length of self.words I greater equal to n, right, return 0. Otherwise, we want the longest alternating subsequence starting at index I actually, we don't even need a bit. If I in self.memo of I bit is equal to self.groups of I insert bit is in 0 or 1. Right, then we'll say for j in range, I plus 1 equals 1. Let's check n. If bit doesn't equal group, if group doesn't equal self.groups, groups equals self.groups. Groups of index j. Max of res and 1 plus a self.dp from index j. Equals none. N. Length equals 1 plus self.dp of j. If length greater than res, this length next index equals j. Okay. And here we have this. One comma none. Res, yeah. Self.dp print f string of 0 equals, or for I in range of word So. Self.memo equals this. Okay. One comma none. Maybe we should make next index be I itself. Maybe we have a self.prevdict. Right. Here we just return res. Return 0. Return res. F string. Self.prev equals. Oh, just how bloody inspiring. Start index, best index equals none. Range 1 command. Set.dpli equals none. If res less than length, res equals length, best index equals index. So best index is not none. Best length. Length is better than best length. Best length equals none. Okay, where does it go with this? Best index is not none. Words of best index. This index equals self.prev of best index. Return string.join res backwards. Okay, that's accepted for those two cases. Is it accepted in general though? No, it is not. Beautiful. Okay. Maybe I skipped the backwards part. Oh, it wants a list. What the hell? Oh. Oh, what the hell? Wait, what does it want? Oh, the words might be longer than the letter. Okay, sure. Res backwards? I see. Okay, sure. I get another wrong answer. Okay. Self.dp of. Self. Or maybe this is fine. Okay. There might be a deeper issue here. Yeah, for an easy, this is okay. Okay. Yeah, there's an easier way of going about this. If we don't need a self.ref, here's what we're going to say. Let's equal to this. Index in range. S index plus 1. Words of best index. Best length minus 1. equals length minus 1, want length. Then we'll say res dot append words of index want length minus or equal to 1. Zero. And break. Turn. Res. Interesting. Well, that would make sense. We want best length here. Okay, there we go. Submit. And there we go. Completion streak 303 days. Consistency is key. See you tomorrow. Okay, what a... For an easy, this is not the easiest easy in the world. If I had that check right here, does it make things faster? Still at 19 ms. Damn, man. Dynamic programming in an easy is kind of rough. Kind of rough. Yeah, here we can probably get rid of that. Any prints we can get rid of. Still 19 ms. Wow, okay. Is there a linear way to do this? Is that why? It's like, how do you know there's, you know... I mean, okay. I know the longest increasing subsequence has a better way of solving it than the n squared dp way, but I don't know if that's what's going on here. And that's why people have a much faster solution. Because beats 5% is kind of sus, right? I mean, it is a solution at the end of the day. So there we go. Okay. That's pretty much it. I mean, I'm just surprised at how slow it is, but okay. Maybe there was a better way of solving it, but I just did it the way that I thought of immediately, which is dynamic programming. This is basically, you know, it's the longest alternating subsequence. I just realized this is basically longest increasing subsequence, but the criteria is different, right? Instead of like, you know, wanting longest increasing, you want longest alternating, right? But same problem. At the end of the day. Okay, so nevertheless, as always in all my videos, I do a quick recap if I was able to solve the problem. So this one, if I come into LeetCode, not necessarily courses, right? But if I come into practice and I come into dynamic programming and I click on, longest increasing subsequence, this problem really reminded me of this LeetCode medium that I know how to solve very well. Which essentially this problem is given an integer array nums, return the length of the longest strictly increasing subsequence, right? And the way that you do that problem is essentially, well, spoiler alert over here, you divide the problem into n subproblems, which is that for each index I in nums, you're going to say what is the longest increasing subsequence that starts at index I, right? And inside each of these IDP calls, possible DP calls, right, one for each possible index in nums, you'll end up doing O of n work in the body in total. And then once you've done that once, it'll be O of 1 for the rest of the time. So the overall time complexity happens to be O of n squared for this problem. I know there's a way to solve this problem in non-DP way, I think in divide and conquer with like binary search and like n log n time. I don't know if that's why people have a faster solution, but I'm guessing there's probably some trick to this because it was a LeetCode easy. Whereas this problem is essentially just a different version of this problem right over here. Because what this problem is asking for is longest strictly increasing subsequence. The other one is just like, basically give me the longest alternating subsequence where instead of like, you want longest increasing, which means that each next number is bigger than the previous one, you're just like, okay, you're given an array groups, and so you want for every single index in the subsequence that for every single if you have this group of indices, right, and you have them as I0, I1, all the way up to ik minus 1, you want groups of ij not equal to groups of ij plus 1 for each j between 0 and k minus 1, right? So that means that, like, every single index you choose, each adjacent index must have different group value, right? So groups of I0 must be different from groups of I1, which must be different from groups of I2. And groups can only be zeros and ones, right? So there you go. So essentially, this problem really becomes about finding, the longest alternating subsequence that you can find inside of groups, and then take that longest subsequence and map it to the indices inside of words, right? So here I can remove these comments. But I think this is definitely a better problem to solve first if you're going to do the dynamic programming approach in the exact way that I did, because essentially this will teach you, okay, so the idea behind this is that, okay, you divide into n subproblems, so you divide into finding the longest increasing subsequence from index I for every single index I, and the way you do it is you loop from, okay, index I plus 1 all the way up to the end, and for every single index after index I, you check, okay, what is the value at that index? Okay, if the value at that index is bigger than the value at index I can continue the subsequence from here, right? So for each of those cases, right, for j in range I plus 1 to the length of nums, if it is the case that nums of I is less than nums of j, that means I could continue the sequence from here. So a new possible case is that the length of the sequence would be 1 for my current index I plus the length of the longest increasing subsequence from index j onwards, right? And if my current best result is less than the length of this new potential case that I could be using, then I have the result, right? And I do this for every single possible index j after index I, and eventually I'll have to find the best one, so then I just catch the result and return it, right? And I do the exact same idea here. Or my DP function, if it's in my memo, return it, yada, yada, yada. If I is greater or equal to n, then okay, you can just length 0. Otherwise, it's like, okay, let's grab groups and let's get the current group that we're at, which is going to be groups of index I, right? And it's like, okay, loop through every single index j after index I plus 1 all the way up to the end. We want it to be alternating, right? So as long as the current group doesn't equal the group at index j, this is a new potential candidate, right? So the new potential case will be 1 for the current index I plus the longest alternating subsequence starting from index j, right? And if that length is indeed better than our current best result we have so far, then we update the best result and then at the end memorize it and return it, right? Exact same spirit as longest increasing subsequence. It's just instead of checking, like, if nums of I less than nums of j, it's just like, okay, if the current group at index I doesn't equal the group at index j, i.e. if it's alternating, right? And then since we don't want the length but we want the actual subsequence itself, what we do is like, okay, let's grab the best longest increasing subsequence. So the way that I did it here is like, okay, you have the longest increasing, DP of I will be the longest increasing subsequence starting from index I. You don't know which one to start with, so try them all, right? Grab the maximum out of, like, longest increasing subsequence starting from index 0, the one from index 1, starting from index 2, starting from index 3, grab them all and return the maximum one, right? So here we do something similar in spirit, where it's like, okay, we go through every single possible index and we grab the length of the longest increasing subsequence starting from that index, right? And then we'll store whatever happened to be the greatest length and the index that it started from, right? And then what we'll do is like, okay, let's say, it's index 3 with a maximum length of 5, right? Then it's like, okay, let's put in the index 3 into our result array, and then it's like, okay, we need to find the next 4 elements, right? So let me go through every single index after the current best index and be like, okay, let's look for something that has the longest increasing subsequence of 4, right? So self.dp of index is equal to wanted length. That's like, okay, we have found, you know, an index which will have a longest increasing alternating subsequence of length 4. So let's add that to our result, subtract our wanted length by 1, because now we only want 3 more inside of our subsequence. Obviously, if want length is equal to 0, we break because there's nothing else that we want. But then we keep going, right? Because now we just confirmed a new index, but now we only want 3 more indices. So let's keep on going through the indices until we find one that has a longest alternating subsequence of 3. Add that to our result, then do it for 2, do it for 1, and yada, 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 right? This is just the solving the original subproblem part of the DP function. But at the end of the day, the overall asymptotic time complexity of this function is O of n squared, which is seemingly a little bit slow for this problem. So maybe there's a cool trick that one of you guys know in order to solve the problem, and can let me know down in the comments below. But otherwise, that's pretty much it for how I solved this problem. I basically just followed the exact same spirit of this problem over here, which is longest increasing subsequence. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful, enjoyable, and in shape or form, I'd highly appreciate it if you left a like or a comment. But otherwise, I'll catch you in the next one. So till then, ciao, ciao, my friend. Bye-bye.